Hello friends, welcome back. In this video, we are going to start the case study of the super high-rise building from the Middle East. So the actual thing is, considering the HVAC system, it has plenty of parts like I mentioned here, chilled water system, AC duct supply and discharge system, then we have the ventilation FHU system, the smoke management system, car park, the staircase, lift, corridor pressurization. Then we have the miscellaneous ventilation arrangement like fire pump room, generator room, garbage collection room, FCC room, etc. So because of the lengthy section of the video, I have split this video case study into multiple parts. In today's video, we are going to see what are the design and installation consideration we have to make when we go for the chilled water system. The chilled water system, we have plenty of options, like we can go with the chiller, air cooled chiller, water cooled chiller, or district cooling system. For this super high-rise building case study, I have taken one district cooling system and I am going to explain each and every detailed design criteria. When it comes to design, the people will always think about the space allocation. That is the key role and key point of every design engineer who has to have very detailed understanding about the space allocation. And additionally, I am going to explain the lots of key rules you have to consider when you go for the design and installation. So let's start the video. When it comes to chilled water system, as I told, in this video we are going to explain, we are going to consider and think about district cooling system. So whether it is district cooling or chilled water system, the key, the important thing is about the pipe sizing. So we have lots of methods to go for the pipe sizing. As I shown here, we can follow the ASHRAE application handbook for the pipe sizing. So what is mentioned in the ASHRAE application handbook is till 2-inch pipe size, you can go with 4 feet per second velocity. So this method is called as a velocity plus friction method. Why I am telling particularly like this? For example, till 2-inch, you have to make sure that your velocity in the pipeline is not exceeding 4 feet per second. When it is more than 2-inch pipe size, you have to consider the friction loss is not exceeding 4 feet in 100 feet. So this rule mostly, based on my experience, I follow for all the project for the pipe sizing design using the ASHRAE application handbook. When it comes to some local regulations, for example, if you see the Dubai building regulation, what the key factor they are adding here is the maximum pipe velocity shall not exceed 1.2 meter per second for sizes till 50 mm, and this can be increased to up to 2.5 meter per second when it comes to 65 mm and larger. So this, if you go with this idea, you can see the velocity limit till 2-inch. In this case, I can go 4 feet per second. That is approximately almost equal to 1.2 meter per second. So the ASHRAE application handbook and the Dubai building regulation almost consider the same value. When it comes to more than 50 mm, ASHRAE application handbook says consider the friction loss of 4 feet per 100 feet. Forget about the velocity. But when it comes to Dubai building code, they are talking about the velocity. You can go till 2.5 meter per second. And same time you have to make sure that the pressure drop shall not exceed 250 pascal per meter for all pipe size. So these are the key points we need to consider when we go for the pipe sizing. The next very important thing is the chilled water or district cooling system available limit in that particular area. If you go to Qatar or different parts of the UAE, for example, if you go to Abu Dhabi, you have the Tabreed district cooling system. If you go to Dubai, you have the Empower, Emicool. So there are different things are available in the based on different area. If you go to Qatar, you have the Qatar Gold, and also if you go to other parts of the Qatar, you have the other network district cooling system. So what temperature we can expect from the central authority, I mean the district cooling service provider. For example, in this chart I have taken from the Dubai Empower, you can see the primary incoming temperature is 4.5 and 13.5 degrees Celsius. So this chart is from the Abu Dhabi Tabreed. So here you can see the entering and leaving temperature, that is 4.4 and 13.3. So this temperature from the authority will vary based on different area. You have to consider this temperature for the primary side, and based on this primary side, you can go with the secondary side temperature for your FCU and all the air side equipment sizing. For example, in the incoming temperature is 4.5 and 13.5. This is the incoming temperature from the Empower. So in the Dubai side, when it comes to secondary side, you can see there will be at least 1 degree increase in temperature. For example, here it is 4.5 means the secondary side it will be 5.5. 13.5 means it will be 14.5. So 1 degree increase in temperature must be there. So when it comes to super high rise building, the question will come that how many heat exchanger I have to provide. So I will take one example related to the Dubai code. Then just to explain the actual concept behind this logic. For example, if you have a super high rise building, let's say that it is 2 or 300 meters. Let's say we will say the super high-rise building with 300-meter height. So if you say 300-meter height, the thing is like if you provide only one plate heat exchanger ETS room here, and from here if you pump till the 300-meter height, so there will be plenty of challenges we have to face. For example, as I told, it is 300-meter height. That means what is the static head? For example, 300-meter height means 1 bar is equal to 10 meter. So if you divide by this one by 10 meter, it will be 30 bar. So this 30 bar means, for example, this is a static head. Static head is 30 bar. That means all your pipes should have 30 bar minimum pressure rating. The pump pressure head will be very high. So all this thing will increase the limitation in the system. So this is one of the important thing. And for example, if you go to country like UAE, they have a very strict regulation. For example, what their consideration is, any building more than 90 meter, you have to provide one mechanical floor. That is a rule in the UAE. For example, if you have 300-meter height, then how many mechanical floor you have to provide? Let's say like 300-meter height, 300 divided by 90. So at least 3.3 mechanical floor you have to provide. That means 4 mechanical floor in the building you have to provide. So you cannot limit only one heat exchanger here. So additionally, there will be multiple heat exchanger will come in between that. Okay. So let's say how it will affect the temperature. So here what we saw, the incoming temperature is 4.5, 13.5, and the secondary side it is 5.5, 14.5. So I will just go back to the actual scenario. So from the primary secondary side, now it is 5.5 and 14.5. This is the secondary side temperature. So from here I have the supply system which is coming with the 5.5, 14.5. But as I told you, there will be multiple in between heat exchanger will be there, because as I told you, the height must not exceed 90 meter. So each 90 meter you have to provide one mechanical floor. So there will be additional multiple heat exchanger will come in between that. So here after the main heat exchanger, the secondary side, the temperature is coming, as I told, it is with 5.5 and 14.5. Okay, this temperature it will come. When it comes to the next heat exchanger, the other side again it will be increased. For example, I show you one diagram for your clear understanding. So like you see here, this is the main plate heat exchanger. The incoming line from the authority is coming with 4.4 and 13.3, and this side it is 5.5 and 14.5. The secondary side temperature. So here you can see there are different kind of pumps we have. For example, this is the primary pump which is supplying the water to the plate heat exchanger. We have two different pumps. One is the secondary pump, another one is the tertiary pump. So what is secondary pump? The secondary pump will supply the water up to some particular height. For example, here you can see I have two loops. This is one loop and this is one loop. So this loop, for example, you can see one kind of supply temperature which is going to another mechanical for heat exchanger. Let's say if I go upside, you can see there is an intermediate flow. There is another heat exchanger in the intermediate flow. So as I told, if you have high super high rise building or any kind of like a 400, 300 meter height, whatever it is, you have to have multiple heat exchanger. So now the temperature which is coming from this line is 5.5 and 14.5, and after the plate heat exchanger, there will be at least 1 degree Celsius increment in the temperature. So if it is 5.5 this side, this will be 6.5. If it is 14.5 this side, this will be 15.5. So there will be again a changes of 1 degree Celsius increment at this level. So this is for one line, and also you can see the another line which is coming this side. For example, if I go down, you can see. So here we have two loops, as I told you. One loop is supplying the water to the another heat exchanger which is located in the mechanical floor. Another pump is supplying the water to the first floor till the mechanical floor. For example, if I go to the top side, you can see the supply line till this level. Okay, till this level, this is the supply is happening. So all this area of supply is happening from one pump, and one pump is supplying the water to the intermediate level heat exchanger. Again, this will go After this one, again it will go upside. So if the building height is more and more, there will be another plate heat exchanger in the another mechanical flow. So there will be another again 1 degree Celsius increment will be there. So this will be keep on following like that. So here I would like to add a few important things. It is recommended to install FCU ducted type unit for the complicated serving area like electrical room, telecom room instead of DX split unit. For example, you have one telecom room here, main telecom room. If you provide the DX split unit inside wall mounted unit, there is a chance that there will be some leakage in the from the system through the CDP, something like that. So that will make the serious issue inside the room. That's the reason we are providing the FCU unit and we are providing the ducted supply only like this, and here we have the grills, okay, to avoid this kind of leakage. Or if you are providing the DX split unit, you have to provide the additional dip tray, GRP tray, or the stainless steel tray you have to provide to collect the CDP leakage in case. So this is one rule, and when it comes to any second rule, any piping or ducting should not pass below substation. For example, let's say that this is the system you have, this is the ground floor, and this is the basement floor, this is the ground floor. Okay, so what happened, you have the substation. For example, this is the section, right? You have the substation at this level, and it is the local regulation that you should not pass any piping any ducting exactly below the substation. That is not allowed. For example, you have the transformer room, exactly below the transformer room you are not allowed to pass the piping or ducting in that way. Okay, so this is one of the important thing. So FCU installed in the exposed area like a parking or unconditioned area should be double skin. For example, if you see any kind of FCU installation, we normally classify like a single skin, double skin. Single skin installation, you have to have the FCU in all the conditioned area. But when it comes to exposed area, maybe in the roof or in the parking area where we don't have AC, you have to go with a double skin installation for the FCU. And coming to the next important thing, here you can see, for example, this is supplying to one floor. In this floor, what we have in the supply line, we have the isolation wall. In the return line, we have the double regulating wall. This is for the balancing purpose, chilled water balancing purpose. We have provided the double regulating wall in the return side. So what's happening here? This is going to supply to one FCU. For let's say that this is going to supply to one FCU at this point. So if you have the multiple FCU here at, for example, this is apartment 1, this is apartment 2, this is apartment 3. We have to monitor the thermal consumed energy through BTU meter. So first this connection will go to one BTU meter room. From the BTU meter room there will be multiple meters. For example, this apartment 1 meter, this apartment 1 meter, and this apartment 1 meter will be there. So there will be 3 meter in this BTU meter room. From there the supply will go to each apartment, so we can monitor the consumption. So there is a rule. There are different authorities have different rule. So the minimum size of the BTU meter should have some size. For example, if you go to the Dubai Empower, the rule is saying that minimum length of the BTU meter room should be 2.5 meter or 250 centimeter. The height should be minimum 2 meter at 200 centi, and the depth of the room should be 50 centi or 500 mm. So this is the minimum size of the BTU meter you have. If you have 10 apartments, 15 apartments, 20 apartments, based on that you can provide the size. You have to make sure that 5 centi, you can see this gap they have given, 5 centi distance between the pipes you have to consider. Okay, so this is one of the important thing to consider, the BTU meter size. Now coming to the very important thing is about the ETS room. So when you go for the concept design, the important thing I will say, the space allocation. How to provide the minimum space for the heat exchanger, the pump room and other thing. So normally what happens when it comes to ETS room sizing, different authorities have a requirement. For example, let's say if you go to Dubai Empower, so what is the minimum authority requirement is, for example, if your capacity is between 0 to 500 ton, or your capacity between 500 to 1000 ton, or 1000 to like 1500 ton, different category they have. If your capacity is between 0 to 500 ton, they will say that you have to provide minimum 2 heat exchanger, and the distance between the heat exchanger should be 1.2 meter. There are some rules, but apart from that rule, I have one basic rule you need to consider for all the cases. So what is that rule I consider? The back side of the heat exchanger, at least 1 meter clearance you have to provide. That's a minimum. 1 meter is sufficient for any capacity. 1 meter is sufficient for the back side, because we don't have any piping in the back side. In that case, if you in the front side, I will recommend to provide minimum 3 to 4 meter, because if you are taking for the wall connection, all the wall connection you are making in the front side, so you have to provide minimum 3 to 4 meter piping space allocation in the front side, and this side and in between the plate heat exchanger, at least you have to provide minimum 1.2 to 1.5 meter based on the higher capacity. Because normally minimum 1.2 meter you need to provide in between the heat exchanger, and also end of the heat exchanger also. If you, for example, this is the wall, you have to provide minimum 1.2 meter spacing. Okay, so this is 1.2 meter, this is 1 meter, and front side 3 to 4 meters spacing you have to provide, because front side you have to collect all the pipeline. So in this case, you see I have taken the incoming line is coming from here. I have taken the connection like this, so that's why I have to provide additional clearance here. But normally what I provide, if you are taking line like this, if you are making front side connection, then 3 to 4 meter clearance you have to provide. Then from here you have to go to the pump room. Okay, in this case, what we have done, we have taken the line from outside like this. It is entering like this, and it is going to the heat exchanger, and same area we are taking back to the pump room. When it comes to pump room, so what the key thing is, what type of pump you are using. Are you providing end suction top discharge pump, or are you providing the horizontal split case pump, or are you providing vertical inline pump? So what kind of pumps you are providing? For, if you ask me, I would recommend to go with the horizontal split case pump. That is my first choice, because it has the best hydraulic efficiency. The horizontal split case pump, I would always recommend to go with that one. But if you go with a horizontal split case pump, you have to make sure that you are providing sufficient inlet and outlet clearance. But because some manufacturer will say I need minimum of 5D clearance in the front side. 5D means 5 times of inlet pipe dia they have to provide in the suction side. Discharge side also they will ask a minimum clearance, so you have to ensure that the minimum clearance is available. If you cannot provide minimum clearance, you can go with the best choice, that is end suction top discharge. Okay, so suction, end suction, top discharge, like this. Okay, so you can reduce the clearance side. So based on that you can provide. So normally this pump spacing 1 meter by 2 meter I will provide for all the pumps except vertical inline pumps. Then in the front side provide 1 meter, and this side also provide minimum 1 meter spacing, 1 meter and 1 meter spacing for the wall connection. Okay, front side 1 meter minimum we need for the strainer, valves and other connection. Like this, all the pumps you have to provide when you go for the space allocation. This is one of the very important thing for the complete chilled water system. In addition to that, this is the screenshot from the Empower minimum requirement, which is followed in the Dubai. So what is that? So ETS room, the door size should be width should be minimum. This is the door. This is about the door. If you have the door like this, the minimum width should be 2.4 meter, and here it should be 3.5 meter height. We have to follow, and the door should be solid type. It's not about the lower and something. It should be the solid type of door. And friends, 1 minute. We work hard to collect all the information from various sources to give you best understanding of the subject. Most of the people watch the video but they don't subscribe. Please motivate us by subscribing our channel to post more and more technical videos for you. Thank you. The important thing is like you have to provide 5 meter by 3.5 meter clearance before you close. They have to provide they have to shift the heat exchanger inside the ETS room. So you have to provide the opening of 5 by 3.5 meter. Once you shift the heat exchanger inside the ETS room, then you can close this 5 by 3.5 meter opening. Then the ETS room property of the Empower. Okay, that means you have to provide the key to the Empower. This is only the property of the Empower. They will control the Empower. So then the important thing is like whenever the pipe is enter into the ETS room, you have to provide the puddle flange or sleeve. Then dedicated corridor for DC pipes from network to ETS room. For example, if you are taking the line from outside to the ETS room, this is the ETS room, there will be a dedicated corridor should be there. You should not mix with the water supply, firefighting, something like that. There should be a dedicated corridor should be there. Okay, no other service are allowed. So inside the ETS room, you can provide the firefighting with sprinkler. This thing that is a compulsory life safety device. Other than this one, don't provide any don't unnecessarily pass the water supply, drainage, LPG, this kind of thing inside the ETS room. That is not allowed. Okay, so these are the minimum requirements for the ETS room. I just took the example from the Empower. Similarly, if you go to other authority, they have the additional requirement that you have to consider when we go for the chilled water system. So I hope in this video I have explained the key rules and the space allocation and other important thing about the chilled water system. So in continuation of that, the next video I will similar to this arrangement. In the continuation of the next video, I am going to explain each and every rules, regulation of the space allocation and how the designs are proceeded and the installation requirements in the as a part of the case study we are going to discuss. So thank you for watching the video. We will meet you in the next video. Thank you.